So let's begin this video right here. Hopefully you guys already jotted down the title, 4.2, Solving Quadratics by Graphing. We should already know what a quadratic is. It's anything with an x squared, right? An equation x squared equals 9 is a quadratic. X squared minus 3 equals positive 6 is a quadratic. Anything with an x squared in it is a quadratic. We should know the two different forms, vertex form, standard form. And you know what, before even beginning with the lesson, let's begin by reviewing a little bit of algebra. Does anybody know how to find an X-intercept and a Y-intercept algebraically? You set what to 0? Okay, so if you're trying to find the X-intercept, you set Y equal to 0. To find the Y-intercept, you set X equal to 0, right? If you do not know that, please jot this down right now. To find an X-intercept, we must set Y equal to 0. To find a Y-intercept, we must set X equal to 0 and solve. Now, the reason why the question says, how do we algebraically find an X-intercept and a Y-intercept? Because obviously, if you had the visual graph of the parabola, where's the X-intercept? It's simply where it crosses the X-axis. Where's the Y-intercept? It's simply where it crosses the Y-axis. So this is when you do not have the graphed parabola. You could solve it algebraically. To find an X-intercept, you set Y equal to 0 and solve. To find a Y-intercept, you set X equal to 0 and solve. And we should remember that a standard form quadratic trinomial equation, like let's say you had y equals 3x squared minus 4x plus 6. And I told you find the y-intercept on this guy. Well, you simply set x equal to 0. So you take the zeros and put them right there where the x's are at. Everything cancels out and your c value is your answer. So we should remember this from the past, that finding the y-intercept on a standard form quadratic trinomial is the c value. And that's like one of the easiest things to do. Anyway, are we ready to move on? And of course, this is for solving with algebra, and we're going to be solving with graphs. So this is a PDF that you guys have in Google Classroom, but I only want to focus in on the second half of it. And for you guys right now, I would like you to copy down these words right here. Solutions, X-intercepts, roots, zeros, and you know what? We could even do this. Some books or some textbooks or worksheets, they call them real zeros. I want you to write a list of all these phrases, words, and we need to recognize that they all mean the same thing. What are these guys? These are all answers. So jot that down. Solutions, X-intercepts, and notice it's not Y-intercepts, it's just the X-intercepts. The roots, the zeros, the real zeros, all of those just mean answers. And if you do look at the PDF and actually read right below it, right there, it says all mean the same thing. When it comes to quadratic equations, they are all answers, okay? So that's what we need to learn today. That if I give you a quadratic equation and I tell you find the X-intercepts, it's the same thing as finding the answers. Find the roots, same thing as finding the answers. Find the zeros, same thing as finding the answers, right? Solving, that's what we're doing. So all these words mean the same thing. So this is why I walk through these examples I'm about to do with you right now. Question 1, it says, what are the solutions to the simple quadratic equation x squared equals 9? And again, right here, they're asking for the solutions, which we know that just means answers. So what number could you actually plug in that'll give you a right answer? 3, right? So x equals 3, that's for sure an answer. Is there any other values that'll work? -3. That's exactly right. So you guys understand when they ask you find the solutions, right? Right here, it says, what are the roots? So what I want to walk you through right here is why all these words mean the same thing. When I say what are the roots, I'm really asking you, what are the answers? And where does the word root come from? Check it out. If you wanted to solve this equation, the traditional way of getting x by itself, you wouldn't want this square. And whenever you don't want something, you could get rid of it by doing the opposite. The opposite of a square is a square root. I hope you guys know that. And what you do to one side, do to the other side. So the square root of x squared, that eliminates the square, and you just are left with the x. And whenever you do apply a square root on an equation, you must remember to put a plus or minus in front of your answer. And the square root of 9 is 3. And of course, this is not the section that we're focusing in on this week, but I do want to show you why the word or the instructions find the roots mean the same thing as find the answers, right? Because right here you have two answers. You have x equals positive 3 and x equals negative 3. So it's the same problem, just with the different words on the instructions. What are the solutions? There you go. What are the roots? There you go. And also this last one, what are the x-intercepts? What are the x-intercepts? Well, of course, to find the x-intercept, you must set, to find the x-intercept, you must set y equal to 0 and solve. So here is the y. We're going to put a 0 right there. So we're going to put equals 0, or 0 equals x squared minus 9. And I don't really like saying an equal 0 over here. I would rather write it over here, and that's what I'm going to do. So that's going to be a x squared minus 9 equals 0. And of course, we're going to solve this thing, plus 9 plus 9. So we have x squared equals 9. And you could do the square root to get the plus or minus 3, or you could just think what numbers work in there. Well, that would be a 3 and also a negative 3, because 3 squared is 9, and also negative 3 squared is 9. So again, we get the same exact answers. I just did the same problem 3 times, but with different instructions. And why did I do that? Just so I could get you to understand that the words solutions, roots, x-intercepts, even the one zeros or real zeros, that kind of plays in right here, because whenever you want to find the x-intercept, you set y equal to 0. And that's where the phrase find the zeros came from. So all of them mean the same thing. Do we get it? So we will be able to take a quadratic equation and solve it by graphing. Okay, so we're going to be able to solve equations by graphing. So like this parabola right here, we don't have the quadratic equation of it. That's a skill that we should know. How about that? Let's start with that. What quadratic equation would give you this parabola? Anybody? We know that the vertex is 2 comma negative 1, which is technically an h and k. And we also know that this thing looks like it's going 1 over 1 up, 2 over 1, 2, 3, 4 up. So for sure the a value is what? That's right. So let's write our equation in vertex form. That's the easiest thing. We all learned this last week. Y equals 1. I don't need the 1. Parenthesis x what? Minus 2, close parenthesis squared, plus k minus 1, right? Okay, so there's our equation. Now, let's say I gave you this equation and I told you find or solve it, which means find the x-intercepts. Or maybe I actually gave you the equation like this, x minus 2 squared minus 1 equals 0, and I told you solve it. You could do all kinds of algebra, right? You could move the 1 over, you could square root both sides and then add 2. But if you already have the graph of the parabola and they tell you to solve it, what they're really asking you for is the x-intercepts. And the x-intercept is clearly right here and right there. So what are those x-intercepts? 1 and 3. And that means that your answers to this equation is x equals 1 and x equals 3. Okay, so we're going to be able to solve quadratic equations without doing any math, just by looking at the graph and identifying where it crosses the x-axis. And why is that? Because of what we just learned right now, that x-intercepts are the same thing as solutions or the answers, right? So if we're able to see the parabola, then we technically have the answers to the equation, okay? How about, but see, you're not always going to get 2 answers. What would the answer of this parabola be, even though we don't know the equation? What would be the answers to this quadratic equation, even though we don't know the equation, if I have the graph of it? That's right, 2. X equals 2 is the x-intercept, which makes it the solution, right? How about the answers here? What's the answer here? There is no answer. There is no solution. No solution, okay? So again, the goal for today is to understand that x-intercepts are the answers. And for the future, it's good to know that all these different words mean the same thing. The roots, the zeros, solutions, x-intercepts, they all mean answers. But today, we're going to be able to solve quadratic equations just by looking at where they cross the x-axis. All right? Now, it's true that they're not always going to cross at nice values like 1 and 3. Maybe your parabola crosses between 2 and 3. But this week, I want to give you nice parabolas that have nice X-intercept values. And on the test, that'll happen also. In the future, we're going to get decimal values, and that's when we use factoring methods instead of graphing. So this is what you're going to see on the practice test, or maybe the actual test this Friday. I give you, obviously, a vertex form quadratic equation, and I tell you to solve it. What do I mean by solve it? It says right here, state the x-intercepts, right? So how could we state the answer to this thing by looking at the x-intercepts if I don't even have the graph? I want to sketch the graph. It's pretty easy to sketch the graph. Everybody should copy this down, might as well. And just do a quick sketch. Here's an xy plane. How do I start sketching this parabola? Anybody? What is a vertex? Positive 1, 2. Right? So the vertex is 1, 2. Positive 1, 2. So that's 1 on the x, 2 on the y. There's my vertex. Does this thing open up? Does it open down? It opens down because I know that my a value is negative. And it's negative 2, which means I can't really use the pattern 1, 1, 2, 4, 3, 9 as is. What would I have to do? Multiply by that new a value of 2, or negative 2, whatever you want to call it. As long as you remember that it's opening down, you don't have to put a negative. You could just put a 2. Just remember that it's opening down. So instead of the pattern being 1, 1, it's going to be 1, 2. Instead of 2, 4, it's going to be 2, 8. Instead of 3, 9, it's going to be 3, 18. So this is your new pattern. 1, 2, 2, 8, 3, 18. From the vertex, obviously opening down because it's negative. So from the vertex, I go 1 over 2 down. So 1 to the left and 2 down, that would put me right here at the origin. And go back to the vertex and go the same pattern but in the opposite direction. 1 over 2 down and you'll be right here. And there's your sketch. And that's all we really need because they're asking for the x-intercepts. What are the x-intercepts? What are the answers? X equals 0, comma, x equals 2. Now you could say x equals 0 and 2. But this is how I'm going to ask you to type it in on the practice test and also on the actual test. Type in x equals 0, comma, x equals 2. And those are your 2 answers, your 2 solutions to this equation. Now, is there other methods of doing it? Yeah, you could solve this thing algebraically. Like if I told you find the x-intercepts, because that's what I'm asking for right here, find the x-intercepts. You could do it algebraically and you could set this to be equal to 0. And you could solve. How do you do that? You'd have to subtract 2, you get a negative 2 over here. Divide by negative 2, divide by negative 2, you get a positive 1 over here. Square root, right? And then add 1. There's a lot of math to do, but you could still get to those same exact answers of 0 and 2. But I think, well, especially because we're doing that in this section, I think graphing and understanding how to graph and understanding that the x-intercepts are your answers is your best bet this week. Next week, we'll deal more with actual solving and using algebra. This week, we're focusing in on graphing the parabola or sketching the parabola and finding those x-intercepts because we know that x-intercepts really are answers, really are solutions. I want you guys to try this one. Go for it. I want to pause it right now. I want you to find the x-intercepts of this guy or find the solutions or solve this equation, knowing that solving is really finding the x-intercepts. So hopefully we see that this is in vertex form and you're like, oh, I could sketch this pretty easy. Here's my xy plane. What's my vertex? It's negative 3, positive 1. Think opposite on h. Take k for what it is. So if you do go to negative 3 and positive 1, you'll be right here. And this thing opens up because it's positive and it gets vertically stretched by 5. That means that it's pretty narrow. But the whole point of solving or finding the x-intercepts is to see where it crosses the x-axis, and obviously it doesn't cross. So if I'm saying what are the answers, you say that there are no real answers. So you would say no solution. No solution. Or you could write it out, no solution. Got it? you should love these types of questions because they're so easy to answer, right? And so quick. How about this guy? Again, you could solve these algebraically, and I will ask you in the future to solve these algebraically, but it's like it's too easy to not do graphing. I mean, it's too easy to, what am I trying to say here? Graphing's the easiest. What's the answer? The answer is -6. That's the only answer. X equals -6. See, we got the answer because visually we know that this parabola has a vertex -6, 0, which is over here, right? And we know that it's opening down and narrow from this point, opening down and narrow. And if they ask you to solve, they're really asking for the x-intercepts. And what are the x-intercepts if it touches just that one value? Yeah, x equals -6. So yes, we could have solved this algebraically, but just understanding that it opens down and understanding that the vertex is on the x-axis, you already know your x-intercept. It's only one value. And that's your answer. X equals -6. So we should love these types of questions, especially those that are on the x-axis or that don't cross the x-axis. It's really easy. The other ones that do cross, yeah, just sketch it carefully and you'll be able to see where it crosses the x-axis, and those will be your answers. Okay, so obviously these are the types of questions you will have on quizzes. And notice, like, I'll tell you to type in, if you have two answers, type them in, like x equals -8, comma, 9, x equals 9 with no spaces. If you only have one answer, you just type in x equals -6, hit enter. If you have no answers, then you would type in no solution if it doesn't cross the x-axis. But today in class, not on quizzes, in class we're going to have this worksheet. Let's just do this. So we have in the past done all of this already. The only new thing is state the x-intercepts. Now, if they don't cross at nice values, for now, I'll accept a decimal approximation, right? So if it crosses right perfectly between 3 and 4, you could put 3.5, approximately. In the future, when we're no longer focusing in on graphing, when we're focusing in on algebra, we want more specific, exact values. But right now, approximations for the x-intercepts are good. This worksheet's good because it reviews everything that we've done. Let's begin with taking this quadratic equation and finding the vertex. They even give you the vertex formula right here. And to find the vertex, you use the formula -b over 2 times a. And I would replace the b and the a with parentheses. I would identify a and b. There is no c in this one. Or you could put +0 and say that c is 0. But anyway, the b value is -2. The a value is 1. You end up with a -2. That's really x equaling 2 over 2, which is really 1. So we know x equals 1. And whenever you have an x value and you want a y value, all you have to do is rewrite your original equation, y equals x squared minus 2x. There is no c. If you want, you can put +0, but that's kind of a waste of time. Oh, wait a minute. I shouldn't have put x. I should have put parentheses. Okay, so let's plug in our x value of 1 right there and right there. And now let's do the math according to PEMDAS. Parentheses first. There's nothing to do in parentheses. Then you move on to e exponents. 1 squared, that's 1 times 1. It's still 1. Then multiplication. -2 times 1, that's -2. And then, of course, addition and subtraction at the very end. So 1 take away 2 plus 0. 1 take away 2 plus 0 is -1. So your vertex y value is -1. And this is the most important point. You know what, just for funsies right here, even though this was not on the worksheet as a question, what if I were to ask you, now that we know the vertex, what if I told you change the standard form into vertex form? What would the vertex form equation be? Anybody? Y equals parenthesis x minus h. What is h? Minus 1, right? Squared plus k. What's plus k? Minus 1. Good job, guys. This right here is your vertex form. They didn't ask for it. You don't have to do this, but it's just good practice anyway, since we have a test coming up, so we don't forget it. Anyway, let's continue back with what they're actually asking on this worksheet. We already know the vertex. Let's actually graph it. 1, -1. 1, -1 is right here. After that, we usually draw the axis of symmetry, That's this green vertical dotted line crossing right through that vertex. What is the equation of that vertical line? X equals 1. We have to say x equals. That's the only way to get a vertical line, and it will always be the x value of your vertex. What else do they ask? They ask us, use an XY table or a pattern to get more coordinates. Do you guys want to use an input-output table, or do you guys want to use a pattern? Pattern. What is the pattern that we're going to be using? 1, 1, 2, 4, 3, 9. And we do not have to modify it because the A value is 1, and this is the exact pattern that we use for the A value of 1. If you had an A value of 2, all we would have to do is modify the outputs by 2. So let's use this pattern exactly how it is from the vertex, knowing that it opens up because the A value is positive. 1 over, 1 up, put a dot right there. Go back to the vertex. 2 over, 1, 2, 3, 4 up, put a dot right there. Go back to the vertex. 3 over, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm on the edge. And of course, we're going to map all of these over to the other side of the axis of symmetry. And just like that, I have a perfect parabola without a graphing calculator. Beautiful. All right. So what else do they ask for? They ask for the Y-intercept. We are going to give it as a coordinate. Where does it cross the Y-axis? Here's the Y-axis. It crosses right there. What is that location? 0, 0. 0 for X, 0 for Y. You could have also done this algebraically. What do I mean by algebraically? We know that to find a Y-intercept, we copied it down at the beginning of this class. To find the Y-intercept, you set X equal to 0. And if you do go to X's right here, X right there and X right there, and you put zeros right there, your C value will be your answer, which is just 0. So yes, the Y-intercept is at the origin 0, 0. Do we have a maximum or minimum value? And what is the minimum value? The minimum is at -1. That's right. You could have also put the minimum is at the Y value of -1. You could have even put the actual location of that minimum value, which is your vertex. You could have said the minimum is at the location 1, -1. Anyway, domain. What about the domain of any parabola? Don't forget to put x equals, all real numbers. How about the range? Y is greater than or equal to -1. That's right. What else? State the X intercepts. So even if I told you, if I gave you this equation, and the equation said x squared minus 2x equals 0, and I told you solve it, your two answers would be what? 0 and 2. That's exactly right. So in this case, what are your X intercepts? We're going to say x equals 0, comma, x equals 2. And that's how you're going to have to type it in with no spaces between your terms with that comma, separating the two answers on quizzes. Now, I think I posted written out solutions, and I didn't put x equals 0, comma, x equals 2. I'm just getting you used to how you're going to type it in on quizzes. On the answers that I wrote out, I put x equals 0 and 2. But this is how I want you to type it in on quizzes. That's the only new thing that we learned today, X intercepts. Now, most of them we're going to have nice X intercept values like 0 and 2. But if they do happen to cross in between, you could give a decimal approximation. Should we do another one right here on the front page, or should we jump to the back page where we have a value of 2? Back page. I don't know, do you guys want to look at number 6 or number 8, or what do you guys think? Or 7 or 5, I don't care. You want to do number 8? Okay. So how would we find the vertex on number 8? X equals negative b over 2a. That's right. X equals negative b over 2a. When you use the formula x equals negative b over 2a, use parentheses to plug in your b value. What's your b value?
5.
There is no b value, right? Your a value is 2x squared. Your b value is 0x. Your c value is minus 5. Remember standard form, ax squared plus bx. There is no regular x term. So 0x. your C value is negative 5. So I'm glad we're reviewing this, because if you would have messed up right there, then the whole thing's messed up. Anyway, the B value is 0. The A value is 2. We end up with negative 0 over 4, and negative 0 is still 0, and 0 divided by any number is still 0, so the X value is 0. The X value of your vertex, that is. Now, if you know the X value and you want the Y value, all you have to do is plug it in into the original equation. So here's my original equation, y equals 2x squared minus 5, and we are plugging in 0 into that original equation. We should all know that 0 squared is 0, and 2 times 0 is still 0, giving us a final answer. 0 take away 5 is negative 5. So the vertex Y value, after plugging in 0, is negative 5. We have 0, negative 1, 2, 3, 4, 5. Here's the vertex. Are you with me? Cool. Now from there, I need to graph it. I mean, we could state the axis of symmetry, which is the y-axis itself, which is the equation x equals 0, because they asked for it. The pattern that we're going to be using, we're going to have to modify the pattern 1, 1, 2, 4, 3, 9. Why is that? Because we have an a value that's 2, an a value of 2. So with the a value equal to 2, you need to modify your outputs by 2. So we really will have, instead of 1, 1, it'll be 1, 2. Instead of 2, 4, it'll be 2, 8. Instead of 3, 9, it'll be 3, 18. So this is your new pattern that we're going to be applying. 1, 2, 2, 8, 3, 18. Obviously, we won't be able to use all those. Let's go to the vertex and go 1 over and 2 up. 1, 2 up, put a dot right there. Go back to the vertex, go 2 over, 8 up. Right there. I think I did that right, I hope. And obviously if we went back to the vertex and 3 over and 18 up would be off this graph. So that's already good enough. Mapping it over to the other side, we'd have a dot right there and a dot up here. So there is our perfect parabola. Yes, it's a little narrower than usual because it got vertically stretched by 2. So let's continue. What are the y-intercept values? What is the y-intercept value right here? It's at negative 5. That's exactly right. If you were to set x equal to 0, you'd get the negative 5 as your output. Is this a mix or a max value? Min or max value? Min. And again, min is at the y value of negative 5, the y value of your vertex. The domain, always x equals all real numbers. The range, y is what? Greater than or equal to negative 5. Okay, and how about those x intercepts? This is an ugly one because it did not cross at nice x values. So right here, this time, we're going to allow you to approximate, right? So here's 0, negative 1. You could say like negative 1.5 or negative 1.6. And also 1 and maybe 1.6 or 1.5. It's up to you, okay? They're just approximations. So we're going to say that it crosses x, or actually not equals. We're going to put the approximation symbol, negative 1.5, comma, x also approximately is 1.5. So those are your x-intercepts. So what you just mentioned is absolutely right. If we were thinking visually, this is 3 units up, that's 3 units down, so this should be perfectly, if I would have drawn this perfectly, it would have been exactly right here in the middle, right? Same thing there, perfectly in the middle. So yeah, so I guess you could conclude that these are not approximations, these are exact x-intercept values that x equals negative 1.5 and x equals positive 1.5. So yeah, they're exact in this case. But in other cases, they might not be exact, and decimal approximation is good enough, right? Now, again, that's because we're graphing. But next week, when we're actually solving without graphing, we're going to have exact values. So the solutions are posted. Again, this whole worksheet is pretty much a review of everything we've done, and that's great because all of this is going to be on the test this Friday. All right, guys, so let's go back to number 2 and do this one as well. Let's find that vertex. Let me zoom in here to find the vertex, we're using the formula, which obviously will not be provided to you. Negative b over 2 times a. The b value is 4, the a value is 1, the c value is 3. So the 4 goes right here, the 1 goes right there. We end up with negative 4 over 2. So that's really saying x equals negative 2. So that's the x value of your vertex. If you want the y value, you just have to rewrite the original. Instead of f of x, I'm going to write it as y equals x squared plus 4x plus 3. And I'm going to substitute the x value of negative 2 right in those parentheses. And then using the correct order of operations, we're going to do negative 2 squared, that's positive 4. We have a positive 4 times negative 2, that's a negative 8. We have the plus 3 that comes down. Now from left to right, 4 take away 8, that's negative 4, and negative 4 plus 3 is negative 1. So the y value is negative 1. And that is the most important point of the parabola. So let's go to the coordinate negative 2, negative 1. Negative 2, negative 1 is right here. The axis of symmetry is that green vertical dotted line that I always draw right through the vertex. That is the equation x equals simply the x value of your vertex, negative 2. So right here where it says axis of symmetry, everybody should write down x equals negative 2. And now for the pattern, since we clearly see that the a value is 1, we don't have to modify the pattern. It's just that same pattern that we always use, that we have memorized, 1, 1, 2, 4, 3, 9. Again, we're not changing it. If I had a 3 right here, I'd have to multiply all the outputs by 3. If I had a 2, I'd have to multiply all the outputs by 2. But it's a 1, and we know that this pattern is good for all the ones that are positive 1 or negative 1. Anyways, going to the vertex, I want to go 1 over, 1 up. I want to put a dot right there. I want to go back to the vertex, go 2 over, 4 up, right there. Back to the vertex, and I believe 3 over 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. No, 9, right there. Yeah, right on the edge. I think I counted that right, maybe not. Map them over to the other side, and you have your perfect parabola. And now we could answer everything that we can about this parabola. Like, what is the y-intercept value? You could clearly see that the y-intercept is right here at this location, but it's even easier to just look at your c value, because to find the y-intercept, you set x is equal to 0, and your c value will be your answer. So that c value is positive 3, so the y-intercept is positive 3. So you could write it as a coordinate 0, positive 3. That's where it crosses the y-axis. You could have seen it visually crossing at 3, or you could have seen the c value algebraically when setting x is equal to 0. You get that c value of 3. Is this a max or a min? It's obviously a minimum value at the y value of negative 1. So you could actually write that min at negative 1, simply the y value of your vertex. The domain and range. The domain's always x equals all real numbers. And the range is y is greater than or equal to negative 1. Now, the only new thing here, the X Intercepts. What are the X Intercepts of this parabola? X equals negative 1, comma, also x equals negative 3, right? Those are your two answers, your two solutions, your two roots, your two X Intercepts, whatever you want to call them, your two real zeros. Again, all those words mean the same thing. So, that's it.